Well, sorry I'm not here today. Got an appointment with my son, go to the doctor, but I'm going to leave you in the very good hands of Miss Anderson here. So let's just finish off topic 3. If you'll go to your notebooks and please open them up, make a new Cornell note page. And this time we're going to go ahead and label it photosynthesis rates. So RATES should be your heading at the top there. And we're going to actually have two headings in the margins. And the first heading we're going to put in the margin will be light absorption. So we talked a little bit about it yesterday, about how there are different pigments inside a leaf. Chlorophyll is one of them. We also had keratin and xanthines, which absorb light at different wavelengths. And they absorb light at different colors. So just to remind you here, you can see here that light, visible light that is, pretty much is in a very small area right here. And it goes from wavelengths of about 400 to 700. Below 400 would be ultraviolet over here. And above 700 would be infrared, which is not visible light. So visible light is just a small spectrum. And the idea basically is that if it absorbs certain colors, the color it reflects is what it actually looks like. So let's take a look then at the guys involved here. So the major pigments we find in plants are chlorophyll. There's actually two of them. There's chlorophyll A and chlorophyll B. This is what is called an absorption spectrum. So that's the first thing you need to know. What does absorption spectrum mean? So let's write a definition of that. Absorption spectrum means at what wavelength do various pigments absorb light. So let's just talk about chlorophyll A, for example. So I'm just going to draw the curve for chlorophyll A. And you can see that it peaks over here. So it's probably at about 425 maybe. So at that wavelength, it really absorbs light very well. And then it doesn't do so well down here, right? And then it comes all the way back up here, and once again, at about 650 or so, it absorbs light really well. So you can see that in the violet area and in the red area, violet blue, right, that's where chlorophyll A works really well. Chlorophyll B is pretty similar. Let's go ahead and see if I can make another color for it over here. Chlorophyll B peaks at about 450, and then it peaks at, about 640 or something like that. So pretty similar. In other words, the absorption spectrum for the chlorophylls have peaks in the 400 area and about 650. Now you can see that if we look at the other two pigments I had mentioned the other day, they're actually quite different. Let's see if I can get a color here. How about this one here? So if you look, for example, at keratin, which is this guy over here, keratin peaks at around 500 over here. So it's going to absorb light that actually is fairly close to green, and then it'll reflect out different colors. Let me say it again. Absorption spectrum means at what wavelengths, what colors does each pigment absorb light. The reason I'm saying that over and over is because there's something else which is really similar to it, but not quite the same. So this over here is the absorption spectrum we just saw, and you can see it's got several different pigments here. This guy down here is not an absorption spectrum. This guy down here, I'm going to type that in here, is what we call an action spectrum. Okay. This is kind of a subtle difference. What's the difference between the action spectrum there and the absorption spectrum up here? I'm going to spell that one up there so we know. Absorption spectrum. Great. Okay. That doesn't look very good. Let me clean that up. Fantastic. Okay, what's the difference? Well, this guy tells you again how well pigments do at different wavelengths. What this guy tells you is that given any plant, what is the best wavelength that that plant wants light at? So let's just pick, how about a rhododendron, for example, right? Now, rhododendron is going to have all sorts of pigments in there, right? So it's a big mixture, right? It's got some carotene, it's got some chlorophyll A and chlorophyll B. But if you look at the plant all together, where does it like to absorb light? So in this example, this plant here likes to absorb light here at about, maybe 425. And it also likes to absorb light at about 650. In other words, this is probably a typical green plant, since it likes to absorb light in the blue-violet area and in the red-orange area. It probably shows up. See the low point here? The low point tells you it's not absorbing light there, so it's probably this color, greenish yellow, and that's probably what that plant looks like. Absorption spectrum means how well a pigment absorbs light. Action spectrum means for any given plant, where does it want to absorb light at?